Pradeep. Today we are going to present you about the study on multipath characteristic for IEEE 802.15.4g SUN applications in the frequency band using J-band. And here is our overview today. First, we are going to talk about what the IEEE 802.15.4g SUN is. Then we will show you the overview of the purpose of system. Next, we will tell you about the outdoor experiment and the computer simulation of this study. And in the last part, it's all about the conclusion.
Okay, let's start. Have you ever known about the IEEE 802.15.4g before?
It is involved in continuous standardization of wireless smart utility networks applications such as automatic meter reading system, and in this standard, there are three major physical candidates which are FSK, DSSS, and OFDM. But in this presentation, it's all about the frequency band used in Japan, where the service area of SUN is small owing to transmission power restriction. So, we will focus on FSK physical.
Now, let's see the overview of the proposed system.
This picture shows the outing of an automatic meter reading system with multi-hop transmission capability. The meter of electricity, gas, or water corresponding to each home individually transfer its data to the data collection station. In order to expand the coverage area and to eliminate blind spots, relay transmission of such meter data is carried, as shown in the picture.
Now we move on to the next topic. As I told you before, this topic is about the outdoor experiments to evaluate service area and multi-characteristic, and computer simulation evaluation.
For the outdoor experiment, in this case, we employ a transmission power of 10 milliwatts and 700 milliwatts at 5.2 meters and 1.5 meters high, and a fixed antenna at 1.8 meter high. From this experiment, we can conclude that when the transmission power is 10 milliwatts, a received power level of negative 60 decibel is obtained for a range of up to 100 meters, and 300 meters when the transmission power is 700 milliwatts. And the outage probability, which is more than 500 of the subcarriers become degraded subcarriers, is almost 0% for an attenuation of more than 20 decibel, and 15 to 30% for 10 to 20 decibel. This shows you that the occurrence of extensive multipaths is quite rare in the SUN applications in Japan. Now we'll move on to the next topic. OIP graph shows you that in the case of the system with multi-hop transmission, frames are successfully relayed to the station where 80% of all radio links are degraded because of multipath transmission. This is because multi-hop transmissions enable successful relaying and helps avoid link degradations.
And finally, here is the conclusions.
The results of outdoor experiments and computer simulations confirm that no serious multipath degradation occurs in a service area with radius of a few hundred meters, and that the application of multi-hop transmission technology can drastically improve the frame success rate by the use of multipaths, which effectively avoid the degraded radio link. Those results confirm that the use of a single carrier physical for IEEE 802.15.4g SUN applications works well in 400 MHz band in Japan.